Okay, now as you can see, the car, the dog, some cars, bus, traffic light is identified. Okay, so it is detecting that a person is here, as it is 70 to 80% sure that this is a spoon. It says that it is a bottle. Person is detected, so count is 1. Person, spoon and bottle, counter is increased.
Hello everyone, welcome back to the channel. My name is Piyush. This is the week 6 of my 12-week CV journey. In every week, we make crazy CV projects. And in this week, I have made an object detection tool. And without wasting further time, let's hop onto the screen.
So now in the previous week, we have done the image classification, but in this week, we are going to do the object classification. These are the classes of object that this model can classify, which is YOLO library of Python. First, I have read the image that I have imported. Then I have get the original height and width of the image from the image.shape array. Then I have processed the image, reduced its pixel to 640 times 640, swap the BGR to RGB. Next thing, I've get the confidence score in the class IDs. Then I've calculated the scale factor to resize the image to its original shape. Then I've looped through all the 8400 predictions. The first four numbers are the center y, center x, width and the height. So I've calculated them. Then find the highest score in those 80 classes. Like if a car is identified as a truck, so if the chances of truck are 54% but highest prediction of it being a car is 84%, the rectangle must not overlap and there will be only a rectangle. So if the confidence is only above 50%, then only you can identify it as a guess. Then this is all the scaling thing done. Then I have used the non-maximum suppression filter that I have told you just before, like we don't have to overlap 15 boxes on one dog, so we have taken a threshold of it to be 50%, and then draw a rectangle and classify the object. Now let's run this. Okay, now as you can see, the car, the dog, some cars, bus, traffic light is identified. Even the person here is also identified, but as you can see, the car here or here is not identified. So it is the limitation. It cannot just focus on each and every pixel, as it will take a lot of computing power. It has almost everything that I wanted. Now I have assembled all these things, the object detection, into a webcam, so that when I open the webcam, it can detect the surrounding. If I have kept a bottle or a chair or it is a spoon, so it can capture these. Now I've calculated the FPS. The FPS calculation I've previously explained, so it is the same as we have used in the previous weeks. Now let's run this. Okay, so it is detecting that a person is here, as it is 70 to 80% sure that this is a spoon. It says that it is a bottle. Now I have also added a counter function which counts the number of objects detected in the live feed. For that, I've created an empty dictionary that will hold the number of counts. Okay, so it says that if there is a object detected, then label that its class name and its confidence score. Then if another object of the same class is detected, then increase the counter by 1. Then putting a rectangle, so this is the thing that I've previously done. Now drawing the live counts on the screen, pasting a live count text. Okay, now let's run this. Person is detected, so count is 1. Person, spoon and bottle, counter is increased. So before pushing it to GitHub, I have added the ignored the YOLOv8s to the get ignore file. Now let's push this to GitHub. Now let's see if it is pushed to GitHub. Now as you can see, it is pushed to the GitHub.